But what if, when I'm finding a fraction of an amount, what if the amount is itself a fraction? Fractions are just numbers. So much as we can find, say, a half of 12, we could also find half of a fractional amount. For example, find a half of a half. Now what we're going to do is we're going to look at 3 examples here, and we're going to look at them all visually so that we can see what's going on. And hopefully by the time we've got 3 questions and 3 answers, we can turn this into something more proper and see if we can pull some sort of method out of it, I guess. So we're looking for half of a half. Well, first of all, we need to be considering a half. So there we go. I've taken that box, I've cut it into 2 equal pieces, and I've looked at one of them, shaded it in blue, and that blue shaded bit is half of the rectangle. Now I'm being asked to find half of a half, so I'm being asked to find half of that blue shaded area. So I'm going to cut that in 2, and this bit in green, this piece up in the top left corner, is half of a half. Now I should be able to give that as a fraction of the overall shape. It is a piece of the overall shape, it's not the whole thing, therefore we can write it as a fraction. But to be able to write something as a fraction, all of the pieces that we're looking at need to be the same size. And currently we do not have that. We have 2 smaller pieces on the top row in blue and 1 large white piece on the bottom. So really what I need to do is I need to replicate that shape and make it so that all of the pieces are the same size. i.e. so that they're all the same size as that one I've picked out with the green arrow. So there they are. So I've cut the top piece into 2 and I've cut the bottom piece into 2 as well. Now how much of that overall shape am I looking at? Well, I'm just looking at the bit that is picked out with the green arrow. So I'm just looking at that bit there. That is half of the original half, and that clearly is 1 out of 4 equal size pieces. And so we have that a half of a half is a quarter. Okay, but so what? Let's have a look at another example. And this time let's step it up a little bit and let's find a fifth of a third. So the first thing we need to do is we need to take this rectangle, we need to cut it into thirds. There we go. How many of those pieces are we interested in? Just one of them, because we're looking for a third. So there is 1/3 coloured in blue. Now I want to find a fifth of that. So to find a fifth of that, I'm going to have to take that blue third and I'm going to have to cut it into 5 equal pieces. There we go. And I am interested in one of those pieces, picked out with the green arrow. Clearly, that single piece is a fraction of the overall shape, and if we want to write it as a fraction of the overall shape, we need to make sure that the whole shape is cut into equally sized pieces. So I need to look at the middle third and the bottom third, and I need to cut those into 5 pieces as well, so that every single piece in the shape is the same size. So there we go. I've now cut the top, the middle and the bottom thirds into 5 pieces, and we are looking at 15 equally sized pieces. How many of those pieces am I going to colour in for the fifth and the third? Well, just the one up in the top left again, because I'm looking for 1/5 of that top third, and that's the bit we picked out in green. And clearly then 1/5 of 1/3 is 1 out of 15 equally sized pieces, so 1/5 of 1/3 is 1/15. And at this point you might be starting, hopefully, to wonder whether there is some sort of pattern going on. It might be even that looking at the questions and answers, you can spot what you think the pattern might be. If you have a pattern in mind, good, keep it in mind. We'll do one final example that's a bit more complicated, and we'll see if your idea of the pattern holds. And the final example that we're going to have a look at is 4/7 of 2/3. So quite a complicated one. We've not got basic fractions in this, we've got 2 more complicated fractions. Well, we're going to need to find the 2/3 first, because we're finding a fraction of that. So there's my shape there. I'm going to cut it into 3 equally sized pieces, and I'm going to look at 2 of those in red this time. 2/3. So there's my 2/3. Now I'm wanting to find something to do with sevenths of that. 4/7 admittedly, but something to do with sevenths. So that means I'm going to need to take that top third and cut it into 7 equal pieces, and I'm going to need to take that middle third and cut it into 7 equal pieces, giving me 7 vertical stripes, split up by the yellow dotted lines. Now I'm interested in 4 of those sevenths. So I'm interested in 4 of those stripes. And the stuff in that green box is the 4/7 of 2/3. And clearly what's in the green box is some fraction of the overall shape, but I can't work out what fraction until the whole shape is cut up into equally sized pieces. So there's my shape again with the thirds marked in, and I'm going to need to cut that up into 7 pieces with 7 vertical strips. Replicate what's in the green box across to the new one, and that's what we're colouring in blue. And that is 1, 2, 3, 4, 5, 6, 7, 8 pieces out of a total of 21. So 4/7 of 2/3 is 8 out of 21. And now that you're seeing this final example, if you did have an idea of the pattern, maybe that's confirmed it, because there is definitely something interesting going on. All that remains for us to do is to turn these into proper questions, because we never really talk about a half of a half, or a fifth of a third, or 4/7 of 2/3. There's something else that we do with these questions, a different way that we'd write it.
So this is where we're at, but we need to turn these into proper questions. Well, the first thing we could do is we could put equal signs in there. And already they look a little bit more like proper questions. A half of a half is equal to a quarter, a fifth of a third is equal to a 15th, and 4/7 of 2/3 is equal to 8 over 21. Second thing we could do is we could focus on this word of. Now actually, of, bear in mind that these are numbers. A half is a number, a fifth and a third and 4/7 and 2/3, they're all numbers. When we talk about a half of a half, really what we're talking about is a half lots of a half lots of a half. 1/5 lots of a third, and 4/7 lots of 2/3. And we are talking about that because these are just numbers. It's just that we're using of, short for lots of, and lots of means something very particular. Lots of is a nice, easy way of describing a particular symbol. So let's get rid of the lots of and swap in the symbol that lots of tends to be used for. That symbol being times. And now suddenly we have something that looks a bit more like a sum. We have a half times a half, where times is lots of and lots of becomes shortened to of. A half times a half is 1/4. A fifth times a third is 1/15th, and 4/7 times 2/3 is 8 over 21. Now actually, we can do one final thing to this, and that is to see if there is a pattern, a nice method that we can draw out of this. Because drawing pictures every time would work. It absolutely would. We could do pictures every single time, but it takes a long time. So maybe there is a bit of pattern spotting that we can do here that will help us get a proper method. And hopefully you've spotted what it is. On the top, 1 times 1 is 1, 2 times 2 is 4, and a half times a half is 1/4. On the top, 1 times 1 is 1, 5 times 3 is 15, and 1/5 times 1/3 is 1/15th. And finally on the top, 4 times 2 is 8, and 7 times 3 is 21, and 4/7 times 2/3 is 8 over 21. So to times fractions together, all we need to do is we need to times the two top numbers together to get the number on the top of the answer, times the two bottom numbers together and get the number on the bottom of the answer. And then, as a final step, we look at that answer and we ask whether it will cancel down. If the answer will cancel down, then we cancel it down, just because we're always going to try and cancel down where we can, in case we're asked for it. If it doesn't cancel down, it's already in the simplest form, then that's fine, and we can leave it where it is. Two more examples just to prove how quick this can be. 4 over 10 times 2 over 3. So to times fractions together, all we need to do is we need to take the two top numbers and times them together to get the top number of the answer. So 4 times 2 is 8. And then on the bottom, we've got 10 times 3. We're going to times those two bottom numbers together. 10 times 3 to give us the bottom number of the answer of 30. We should then look at that and ask, is there anything that both top and bottom will divide by, so that we can cancel it down. Hopefully we'll spot that there is. They are both even numbers, so we could do divide by 2 on the top and divide by 2 on the bottom and get 4 over 15. Is there anything else they will both divide by? Well, 4 will only divide by 2 and 4. That's going to give us anything useful, and 15 won't divide by either of those. So in fact, the final answer then is 4 over 15 if we're giving our answer in the simplest form. Second one, 5 over 8 times 4 over 5. Same thing again, times the two top numbers together. 5 times 4 is 20. And then times the two bottom numbers together to get the answer on the bottom. 8 times 5 is 40. We look at 20 over 40 and we ask if there's anything that they will both divide by. Well, it so happens that they both end in zeros, which means they're both multiples of 10, so they'll both divide by 10. We could divide by 10, top and bottom, and get 2 over 4. And we might even hopefully spot that 2 over 4 will cancel down neatly to 1/2. And 5 over 8 times 4 over 5 is 1/2. Final example, 2/7 times 3. So we look at this question, it is a multiplying fractions question. We've got a fraction and we've got a multiply sign. We are multiplying by a whole number here. When we multiply fractions, the two top numbers times together to give us the top number of the answer, the two bottom numbers times together to give us the bottom number of the answer. The problem with this is we don't have two top numbers and two bottom numbers. We have a top number, a bottom number, and then a number that's sort of neither. So what does the 3 times by? Do we do 2 times 3? Do we do 7 times 3? Do we do both? Do we do neither? Really, this question will be a lot easier if we were dealing with two fractions. So maybe there is a way to rewrite this 3 so that it is instead a fraction. And it's quite easy to do that. All we need to do is we need to treat that 3 as the top number of a fraction. And we can put it over something, give it a bottom number, so that the bottom number doesn't change the fact that this is still a 3. The only thing we can possibly choose to go on the bottom of that fraction is a 1. Because what this says is this says 3. Remember that that line in the middle is just a way of writing divide. This says 3 divided by 1, and 3 divided by 1 is 3. So what we've done is we have cheated, and this is absolutely a cheat, by writing that second number as a fraction. And now we can do on the top 2 times 3, and on the bottom 7 times 1. 2 times 3 is 6 and 7 times 1 is 7. Is that the simplest form? Yes, it is. There's nothing that will cancel down to. And 2/7 times 3 is 6/7. Let's look at these 3 questions then. So we've got 1/2 times 2. Well, surely that's just 1. And we've got 1/3 times 3. And surely 3 lots of a third would just be 1. And we've got 10 times a tenth. That's 10 lots of 1/10. Well, surely that's just 1. So in each case, these 3 sums give us 1. Let's just focus in a little bit more in depth on what's happening here. Well, first thing, we've just seen with this multiplying fractions type questions that if we are timesing by a whole number, it can be helpful to cheat and to write that whole number as a fraction by putting it over 1. So let's do that first of all for each of those. So rather than 2, we've got 2 over 1. Rather than 3, we've got 3 over 1. And rather than 10, we've got 10 over 1. We've not changed that in any way. We've just written it as a fraction over 1 so that we're seeing it as a fraction rather than as a whole number. But now what's happening? If we go back to our how to times fractions together, well, on this first one, we've got 1 times 2 on the top and 2 times 1 on the bottom. So that's giving us 2 over 2. Which then cancels down to 1. Why? Because 2 out of 2, 2/2 is a whole. 2 divided by 2 is 1. Whichever way you read that, it's cancelling down to 1. 1 times 3 on the top and 3 times 1 on the bottom is 3 over 3, which then cancels down to 1 whole. And on the final one, 10 times 1 and 1 times 10 gives us 10 over 10, which again, 10/10 cancels down to 1. Now in each case, we've got these pairs of numbers, 1/2 and 2, 1/3 and 3, 1/10 and 10, that times together to give us 1. Now it turns out that for any fraction at all, you can find another fraction or number that causes this to happen. For any fraction, you can find another one that when you times them together, you get exactly 1. The name for that is the reciprocal. So if we give that a definition, the reciprocal of any number is what we need to times that number by to get 1. And being able to find reciprocals can be quite useful, if only because a 1-mark question could say write down the reciprocal of, and then a particular number. But let's just focus on these 3 examples. 1/2 and 2 are reciprocals of each other, because when we times them together we get 1. 1/3 and 3 are reciprocals of each other, because when we times them together we get 1. 10 and 1/10 are reciprocals of each other, because when we times them together we get 1. But writing them in this cheat kind of way, hopefully we can see a bit of a pattern. 1/2 and 2/1, 1/3 and 3/1, 10/1 and 1/10. In each case, the reciprocal is the fraction upside down. If we turn this upside down, put the 2 on the top and the 1 on the bottom, we get the reciprocal. Same the other way round. So actually, maybe, and we need to test this, but maybe the way to find a reciprocal is to just turn a fraction upside down. Well, let's just pick a random fraction and test it. So a question could go, find the reciprocal of 4/7. Now, on that kind of thinking that we've just had, the way to find a reciprocal might be to turn it upside down. So let's turn this particular fraction upside down. 7/4. And okay, I get it. That looks a little bit weird. If we're dealing in quarters, how can we have 7 quarters? Hang fire on that. All will be explained shortly in a different video. But let's say that that is the reciprocal. We've turned it upside down to find the reciprocal. We've got 7/4. If that is the reciprocal, we should be able to times them together and get 1. Well, let's do that. Let's times them together. Let's just ignore the fact that that's a weird fraction where the number on the top is bigger. Gloss over that for now, and let's times them together. So on the top we get 4 times 7 is 28. And on the bottom we get 7 times 4 is 28. And look at that, same number top and bottom. 28/28 is just 1, which means that they must be reciprocals of each other. The reciprocal of any number is what you need to times it by to get 1. We've just times them together, we've got 1, which means 4/7 and 7/4 are reciprocals of each other. Our idea about turning the number upside down works, and the reciprocal of 4/7 is 7/4, even though it looks a little bit weird. And this, in the green circle, would be the answer to the question, write down the reciprocal of 4/7. And just to make this super clear, to find the reciprocal of a fraction, simply turn the fraction upside down. So we've already seen that with fractions we can add and subtract with them, and we can do multiplications with them as well. There must then be a way of dividing with fractions. If we can add and take and we can times with them, we must be able to divide with them as the last of those 4 big operations. Problem is, for dividing with fractions, there is no way to do it directly. So adding and subtracting, we have to change the fractions until they're the same type so that we can then collect them or subtract them. Timesing fractions, nice and easy, just times the 2 bottom numbers together, times the 2 top numbers together, get top and bottom for the answer. But divide, there is no direct way of doing divides with fractions, which kind of makes sense when you think about it, because fractions are actually just divides of their own. This 5/8, for example, is 5 divided by 8. So to try and do a divide with a divide, where we're actually dividing by a divide, is quite confusing. The nice thing about that, though, is that if there is no way to directly do a divide, there's no dividing involved. There is a way of doing it, though. There is a workaround, a cheat, if you like. That is the proper recognised way of doing it. There is no way to do the divide. So what we have to do is we have to change the divide into a question that we can do, and then do that question instead, a different question. There are a couple of different ways to show you why this works. Problem is that most of them tend to be a little bit complicated, a little bit faffy, and slightly more hassle than they're worth. So probably the best thing to do would be to show you what to do with these questions, give you the method, prove that the answer has to be correct by working backwards through it after we've got an answer, and then kind of give a hand-wavy explanation of sort of why it works. So what we do for divide questions is we say, well, there isn't really a way to divide directly. So we change the question, and we change the question always in exactly the same way. The first step is to leave this first fraction as it is. So we keep that first fraction as a 5/8. The second step, we look at that second fraction and we swap the second fraction for its reciprocal. Remember, to find the reciprocal of something, we turn it upside down. So what we do is we look at that second fraction and we turn it upside down. And whereas it was 3/4, it becomes now 4/3. And again, it's these weird fractions where the number on the top is bigger, but again, just hold off on it for now. All will be explained shortly. So we flip the second fraction upside down. We swap it for its reciprocal. And then the final step. We can't do dividing with fractions, so we swap the divide for a times. Hand-wavy explanation time now. Why are we doing this? Well, first thing, we can do timesing with fractions, so actually that is a question that we can now answer. And second thing, we've swapped dividing by a fraction for timesing by the reciprocal. If you think of timesing by a half, that's finding half of something. We talked about that when we were doing fractions of amounts and that kind of thing. So timesing by a half is finding half of something, but to find half of something, we would divide by 2. So dividing by 2 and timesing by a half, well, half and 2 are reciprocals of each other, so we could swap a divide by 2 for a times by the reciprocal. And that's where this idea comes from. We take a divide thing that we don't like and we can't do, and we swap it for timesing by the reciprocal. And it's kind of an extension of this. If we do that, then this is the new question, so we can ignore this question up at the top now because we're not doing that anymore. We've kept the first fraction the same, we've swapped the second one for its reciprocal by turning it upside down, and we've swapped the divide for a times. We now do 5 times 4 is 20 on the top, and 8 times 3 is 24 on the bottom. We should probably cancel that down if we can, because it's always good practice to cancel stuff down. So we might notice that we could cancel that down to 10/12 if we divided top and bottom by 2, and then we might notice that we'll cancel that down to 5/6. And our final answer then is 5/6. You probably need some proof that that is in fact the final answer. Well, to prove that, we could work back from the answer to the question. What this question says, yes, it says share 5/8 into 3/4, but that doesn't really make any sense. A better way to look at it would be the how many definition of the divide, the how many 3/4 in 5/8. Basically meaning if we take this and we take the answer and times them together, we should get 5/8. So let's have a go at that. This is the proof section of this. You wouldn't have to do this with the question. This is as far as you'd need to go with any divide question, but we can prove this. So this is our proof section. If we take 3/4 and we times that by 5/6, we would get 3 times 5 on the top is 15. 4 times 6 is 24 on the bottom. Will they cancel down? Well, yes, they will. We can divide top and bottom by 3. Divide the top by 3, divide the bottom by 3. We get 5/8, which is where we started, which is this number here. Proof that it does work. So actually, if what you take from this is the method for divide works because it does, because if you reverse the operation at the end and times it back up, you do get back to where you started. Slightly hand-wavy explanation is it works because instead of dividing by a number, you're timesing by the reciprocal. You're sort of swapping it for an opposite question that works in the same way. It's kind of the same thing. Final example, 3/8 divided by 10/11. So we're always going to do the same thing with these questions. We're going to keep the first fraction as it is. We're going to swap the second fraction for its reciprocal. So it was 10/11, it now becomes 11/10. And whereas we were dividing by 10/11, we're now going to times by the reciprocal, because timesing by the reciprocal will give us the same answer overall. So we've swapped the question for 3 over 8 times 11 over 10. We've left the first one as it is, turned the second one upside down and swapped the divide figure times. On the top then we're going to get 3 times 11 is 33. And on the bottom we're going to get 8 times 10 is 80. As we've ignored this question now, we can just focus on the times that we've rewritten our question as instead. 33 over 80, is there anything that will cancel down by? No, there isn't. So 33 over 80 is our final answer because it is in the simplest form.